Hi! Today I am going to talk about dimensional analysis. Dimensional analysis is a critical skill for any aspiring chemist. What is dimensional analysis? Dimensional analysis is the utilization of a set of set ratios between units to solve simple problems. I know that's a really abstract definition. Here, let me give you a sample problem and show you how it's done. If I am in a car moving at 30 miles an hour and I travel for 100 minutes, how many inches will I travel? I know it's a trivial example, but bear with me. What is important to note about this problem? 1. There are 4 significant figures in each of the numbers we are given. So our answer should also have 4 significant figures. 2. None of our units, miles an hour, minutes, or inches, are the same as each other, so we will need to make many conversions. Now, let's get to work. The first thing we need to do is establish what our units are, miles an hour, and minutes, and such, and determine what we need to do to convert them. Now we know. Now we find the ratios between these values. There are 5,280 feet in a mile, 12 inches to a foot, and 60 minutes to an hour. If I had been given my amount of time in seconds, I might also have to use a defined conversion factor between them. Note, if 5,280 feet are in a mile, then I could say with equal accuracy that in 1 mile there are 5,280 feet. In other words, if there are 5,280 feet per 1 mile, then there is 1 mile per 5,280 feet. Likewise, there are 12 inches to 1 foot. If there are 12 inches to 1 foot, there is 1 foot to 12 inches. Now, by convention, we are not when we are not canceling units, the larger value goes on top. But sometimes that's a useful thing to know. Okay, let's set up our problem. 5,280 feet for 1 mile is the conversion factor, so it does not change the value of the answers, merely its representation. We're trying to cancel units, so we set up the 5,280 feet per 1 mile so that the canceling unit, in this case the mile, is in the denominator if it was in the numerator, and the numerator if it was in the denominator. So because the mile's on top here, it's on bottom here. If the mile had been on bottom here, it would be on top here. In the same way, feet being on top here means that the feet are on bottom here, and the hour being on bottom here means the hour is on top here. That way, the mile over mile will cancel, and you'll be left with 1 by dividing. So you can remove it from your answer. You will note that inches never cancel with anything. This means that we will need to put them in our answer. Note that everything else does cancel, and also note that in defiance of convention, we wrote 1 hour per 60 minutes with the hour on top, even though it was the lower one. This is because that is what it needs to be opposite from the 30 miles per 1 hour here. Also note that the 5,280 feet per 1 mile and 12 inches to 1 foot and 1 hour to 60 minutes do not affect the precision of our answers. This is because these are defined ratios and are perfectly precise. So, our answer has 4 significant figures. Hashing it all out then, we conclude that there are 30,168,000 inches in one, if I move, that is, if I move for 30 miles an hour for 100 minutes, I will have moved 3,168,000 inches. The line merely means that the 8 is the last significant figure. The zeros merely indicate magnitude. We can represent this value in scientific notation as 3.168 times 10 to the 6th inches. Congratulations, you have successfully completed a dimensional analysis problem.